Y'all learn just because you get an answer that's up there doesn't mean you get it right?
Exactly.
Because some of those answers are up there for a reason, right? They're up there because people make mistakes.
Yeah,
And then
don't go far enough.
we know that because these answers are up there because students learn, do you multiply or divide? And that's what they learn. But if you do it my way and you set up the units, it'll tell you if you're doing it right. What'd you get? Okay. So what do we have? We have 34.8 grams of potassium nitrate, and it's contained in 0.225 liters of solution. Right?
Yes.
We're good with that? But that's not what I want. Oops.
That's so annoying, isn't
It is. It's molarity is what I want, and molarity is moles over liters. We already have liters, so what do I need to do? All I need to do is get rid of grams somehow. Well, the only way I know how to get rid of grams is to do molar mass. That 1 mole of potassium nitrate has a molar mass of 101.1 grams. And now, grams cancel. Do that. I erased that accidentally. So now we have moles over liters. We have molarity. So you should get 1.53. Okay? Now with molarity, we can write equalities as well, just like with the percentages, because it's got 2 units on it, right? It's moles over liters, or you can flip it upside down and write liters over moles. I often tell many of my students, when you see capital M, just go ahead and mark that out and write moles over liters, like that. What?
Like molarity.
Molar and molarity, yeah, it does. They all sound alike, don't they?
Yeah.
It's hard to keep them straight, I understand. All right, let's do some conversions. Who thinks they can do this one with no help? Look at Allison, she ready? No? All right, I'll do this one. I'll help you do this one. Then we'll do it. The students in the other class are going, these conversions are hard. I'm like, look, you guys all did the conversions when we were going centimeters to inches, right? These conversions are the same thing. All we've done is change the words. Okay? Let's look at the problem. We have 75.0 grams, it says, of what? Of solution, don't we? And then we also have another number up there. We have 14.0 grams of sodium hydroxide over what? 100 grams of solution. So these are the only 2 things we have, right? We could have molar mass, but we'll wait and see if we need that. Well, let's look at these 2 numbers. Well, look, I have grams of solution here on the bottom, and I also have grams of solution here. What if I take those and bring them together, and I write it like this? 100 grams of solution and 14.0 grams of sodium hydroxide. Why would I want to write it like that? Well, because what happens? Grams of solution goes away, and what unit am I left with? Grams of sodium hydroxide. What am I looking for? It's a puzzle, guys. I've been doing this for over 30 years. I see how the puzzle fits together. For you guys, write down the numbers with the units and look and see where you can cancel things. That's going to help you solve the problem, okay?
We still have to divide it by 100, right? So
Well, it's 75 times 14 divided by 100. So the answer should be 10.5 grams of sodium hydroxide. So I would need 10.5 grams of sodium hydroxide added to enough water to bring the mass up to 75 grams. And that would give me a 14% solution. So I need what, 64.5 grams of water. Does that make sense? A little bit? All right. Think about the units on there and how they fit together to make something else cancel. Can we do another one? Sure, we can do another one. Y'all can do one. Let's take this number right here and write it out. Right? This is my other number here. How am I going to use this number here? Do what?
Just use it the way it is, just drop it into place.
Just drop it into place?
Yeah, 575 on top and 100 on the bottom.
Does that work? How do we know it doesn't work? Because the units don't match, right? Look, I have milliliters of ethanol, and they don't cancel, do they? I gotta flip it, don't I, Brianna? Very good. And the question asks, how many milliliters of solution can you make? What's the answer? Is it C? 39.1 milliliters of solution. So if you started with 2.25 milliliters of ethanol and you wanted to make 5.75%, you would make 39.1 milliliters of solution. Okay?
I have a question.
Yes, ma'am.
When you see volume to volume up there,
Yes.
how do you know you're not looking at liters versus liters and having to convert from liters to milliliters?
If I could use liters over liters. I have to have both of them the same. I could have 5.75 liters of ethanol over 100 liters of solution. But those are large amounts, right? We don't deal with 100 liters. That's a lot. So we normally do this in milliliters. That's just a scaling thing. Because I'm in milliliters, I'm going to use both of these in milliliters, not liters. As long as I have both in milliliters, I'm okay. You could theoretically have both in liters. But that's not normally how we do it. Okay? One more. Hint, you may need molar mass to do this one. What did I tell you to do when you see that capital M? What are you going to do when you see capital M? What is this? What am I going to write? 1 liter of solution. Okay? Or I could write it because I already have milliliters. What if instead of writing 1 liter, could I go ahead and write 1,000 milliliters instead of 1 liter? Can I write that? Is that fair? Sure it is. 1,000 milliliters equals 1 liter, so I'm just going to write 1,000 milliliters. So that should get you guys started.